Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So this question is asking us really to divide the 5 3/4 by 1 3/4. So we're going to do 5 3/4 divided by 1 3/4 because we're finding out how many of each of these towels, which is 1 3/4 meter, can be made when the total amount of cotton is 5 3/4. So first thing we're going to do is convert them to mixed numbers, to top-heavy or improper fractions, because at the moment they're mixed numbers and we can't divide or times if they're mixed. So we times the 5 by the 4 and add it to the top, which will be 20, and then add it to the top 23, and then do the same. 1 times 4 is 4, plus it to the top is 7 over 4. Now a little trick here is KFC. We keep the first fraction, we flip the second fraction, and we change the divide sign to a time sign. So we're going to keep this first fraction as it is, change that divide to a times, and flip the second fraction. Okay, whenever we multiply, we just multiply the tops, so 23 times 4, which is 92, and we times the bottoms, which will be 28. And now we need to convert this back into a mixed number. So first of all, actually we can simplify this because we can divide top and bottom by 4. So that would be 23 over 7, and then make this a mixed number. So 7's into 23 go 3 whole ones, and then obviously 2 remainders, so it's 2 over 7. Now it asks us for the amount of towels that she can sew patterns into. Now the issue here is that she will do 3 whole towels but then have some left over, but she doesn't have enough to create a 4th towel, so it's just going to be 3 as an answer. So we've got to first of all work out how many parts there are altogether. So we're told that the ratio of red, yellow and green is 3 to 2 to 4. So to work out how many parts there are altogether, we do 3 plus 2 plus 4, which is 9 parts. So there's 9 equal piles of sweets. Okay. But to work out what one part or one pile of sweets is worth, we're going to get the 99 sweets and divide it by the amount of piles, and that's going to be 11. So one part is worth 11 sweets. We're asked to find out how many yellow sweets, and yellow is the middle one, so it's going to be the 2. So yellow has 2 piles of 11 sweets. 2 times 11 is going to be 22, so it's going to be 22 sweets. For each of these options, try and construct in your head the triangles that would be made from these lengths. And I'm going to give an example for question D, or for option D. And I'm going to construct my triangle just with sticks. So we're going to start off with our first stick, which is 19 centimeters. Then we're going to do another stick, which is going to be 37 centimeters. And we've got one last stick, which is 61 centimeters. Now, looking at the first 2 sticks, the actual combined distance of them, so when we add them together, so be 19 centimeters plus 37 centimeters, is 56 centimeters. So that's the combined width of them. And you can see that that actually wouldn't be able to create a triangle if the third stick is 61 centimeters. So the side here could combine with this side. So we could move this whole stick here onto this side here, but we can't actually make a triangle with it because the 2 lengths that we've got won't ever reach the end bit here. They just won't ever reach that bit to be able to create the triangle. And I'm just going to put that back. So our answer is option D. So when we say y is directly proportional to x, what we mean is whenever x doubles, y will double. Whenever x halves, y will halve. Now, we've got this proportionality sign here. And to make that an equals, all we need to do is introduce a k constant to the right-hand side. So it's y equals something times x. Now, to find out what that something is, to find out what that constant is, what we're going to do is feed in the value of y and the value of x that we have. So we're going to feed those in. So y is 55.3 and x is 7. So it would be 7k. And we're just going to put our lines in and solve this. So it's going to be divide by 7 both sides. And 55.3 divided by 7 is 7.9. And that's what k is. So we're going to rewrite this equation here, this formula here, y equals 7.9x, and that is actually our answer. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually timesing it by not 1,000, but 1,000 squared. So that's another 3 zeros. You can see here that that's 1,000,000. So we times it by 1,000,000. So 13 kilometers squared is going to be the 13, and then it's going to be times by 1,000,000. So 1, 2, 3. 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him or her 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. The important thing to realise in this question is that we know a female has been selected. So we can just basically get rid of all of this part of the frequency tree because it's not relevant, because we know a female has been selected. So there's 29 females altogether, and we're looking for the probability that the female chosen at random picked action. So it's just simply 16 over 29. So the rules of indices state that if you have a power inside and outside of a bracket, we just multiply them together. So it's 10 to the power of minus 12 times minus 12. 2 negatives make a positive, and 12 times 12 is 144. Just going to write the question out a bit bigger, just so we've got more room. And loads of different methods of expanding brackets. I'm going to do smiles and rainbows. So we just draw a smile rainbow, and I'll put a little line there to remind me to times it. So we do 5 times 7, which is 35, and it's 7x, so it's going to be 35x, and 5 times 4, which is 20. So our answer is 35x plus 20. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. and always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135, and the reason for that is angles on a point. Run out of space. Okay, so we're going to do 360 take away 135, which is 225, and so our answer is 225. So to make estimates from a scatter graph, we've got to first of all draw a line of best fit, which would be something like this. And what we'll do is to find estimate of test score B, given the fact they got 25 on test A, means that we would draw a line up from test A at 25, should be here, and then across, and that's how we'd make the estimate. But look at where that is hitting our line of best fit. It's hitting it here. What do you notice about this position here? Well, all of our data is down here. We don't know whether this trend continues up at this point here. We have no idea. For instance, if you were to plot a scatter graph of height against age, we would see it would increase like that, but that line doesn't continue on forever. Like, you're not a 10-foot giant at the age of 30. You do slowly stop growing, and so we don't know whether the trend continues. So we call this extrapolation. So we say that the data has been extrapolated. And what that means is it is probably not accurate. So when you have the data outside the range of the data, when you have a prediction, outside the range of the data, we say it's probably not accurate. If it was inside the data, we would say it's interpolated, and that's actually quite accurate. Sometimes easier with these questions to multiply both numbers by, say, 10 or 100 or 1,000. So if we look at the 0.06, if we times that by 100, it would make the question a lot easier. But with a division, if you times one of the numbers by 100, you have to times the other one by 100. So we just go times the 30 by 100, and times the 0.06 by 100 to make that 0.6. And this actually is the same calculation as 30 divided by 0.06. The reason being is that you can write that as a fraction. And you know with fractions, you can just times the top by something and times the bottom by something. It doesn't change the fraction at all. It just keeps it exactly the same. So we're going to use the bus stop method to find out what that is. So we're going to divide that out. 6 doesn't go into 3, so carry that. 6 is into 30, go 5, 6 into 0, 6 into 0, so that's going to be 500. So if 2 people liked action but not comedy films, and in total 11 liked action films, therefore there's going to be 9 who also liked comedy, because these two have to add up to 11. Now, if there's 9 who liked action and comedy, and 16 who liked comedy in total, if we do 16 take away the 9, that leaves 7. So 7 only liked comedy. It says there's 23 people altogether, so what we're going to do is take away the people who liked action, the people who liked both, and the people who liked comedy. Take all those away from 23, and we're left with 5. So the answers are going to be 9, 7, and 5. To find the highest common factor, we're going to first of all just write out the factors of 12. So 1 times 12 is 12, 2 times 6, and 3 times 4. And we're going to do the same with 8. 1 times 8 is 8, and 2 times 4 is 8. So those are all the factors of 12 and 8. And we look at the common factors, so they both have 1. They both have 2, and they both have 4. And so the highest of those is the 4. So the highest common factor is 4. To answer this question, we need to know what an equation, expression, formula, and identity is. So the formula is basically an equation but for real world things. So area equals pi r squared. It's where the letters actually mean something. Expression is just algebra without the equal sign. So 5x plus 3 would be an expression. An equation has an equals and it can be solved. So you can find out what x is or find out what a is. And an identity is true for all values of that letter. So an example would be x times x equals x squared. That's an identity because that's true for all values of x. So looking here on the right hand side, we've got 3x plus 2x. But if we imagine x is 10, so 3x would be 30 plus 2x would be 20, 30 plus 20, well that will equal 5x, 5 times 10. And actually this is true for all values of x. And the reason it's true for all values of x is we know that 3x plus 2x, this right hand side here, equals 5x. They're the same thing. Now normally with an identity, it's shown with 3 lines. Now in the exam, this type of question, it won't be shown with 3 lines because that kind of gives it away that it's an identity. But this question is definitely an identity. And you can't solve it because it's true for all values of x. So yes, x could be 10, x could be a million, x could be a third, x could be anything. A frequency polygon is like a line graph. In fact, it's a type of line graph. But it is when you have the data in a group. So we've got the data here as a group of 0 to 80. So there are 11 at 0 to 80. And then 18 at 80 to 160, and 6 at 160 to 240. Now, where am I going to plot this? It will involve putting a cross somewhere on this graph. And it would seem unfair if I put it all at 0, and it would also seem unfair if I put it all at 80. So what we do is we find the midpoint, the halfway point between 0 and 80, which is obviously 40, and we plot our coordinate there. So it seems to be going up in 2s, so it would be there. So that's at 40, 11, the coordinate. Our next one, we plot at the midpoint again, which would be 120, and it's just halfway between 80 and 160, and it's 18 high, so it would be up here. And then the final one is at 200, and it will be 6 high, so 200 is halfway, and we're looking at 6 high, so it will be here. Then when you're done, you need to join them up with straight lines. So I'm just going to get my ruler, join them up, perfectly straight lines, and there we are. So I'm going to write the question out. So y equals x plus 15. And we're told that we want to make x the subject to the formula. Now what that means is we want x on its own. What's stopping x from being on its own? This plus 15. So to get rid of it, we do the inverse, the opposite of plus 15 to both sides. Take away 15. So we end up with having y minus 15 on the left-hand side, and we've got rid of the plus 15, so we've just got x on the right-hand side. So x is equal to y minus 15. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line. And we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11,010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10. 990. Now when we're looking at limits with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,005. and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that V can be anything above the 10,995 and including that, and it can be anything below 11,005, but it can't include that, because if it was 11,005, it would have rounded up to 11,010. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power 4 w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4, w to the power 5. It's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4, w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power 4, w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power 4s together, and remember with indices, if you times two powers of the same base, and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power 5s together, so that makes 10. So it's 121 v to the power of 8, w to the power of 10. In this question we have a right angle triangle and we know two of the sides and we're looking for the third one, so that screams to me Pythagoras. So Pythagoras is a squared plus b squared equals c squared, with c squared being the hypotenuse. The hypotenuse is the one opposite the right angle, so this is going to be c. And we'll label the other ones a and b, it doesn't matter which way around they go. So a is 5, so it'd be 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144. And so 25 plus 144 is 169. Now that's c squared, so we need to solve here, and the way to solve is just to square root both sides. And so it would be 13 equals c. Because it's distance, we don't worry about the negative 13, so just the positive 13. So we know c is 13, so we need to know what the total length around the triangle is. So we're going to add the 5, the 12, and the 13 we've just found. When you do that, you get 30. So we know there's 30 meters in total. Now it does say that we need 90 millilitres of paint per metre of wood. So the amount of paint needed is going to be the 30, because that's the total distance, times the 90, because we need 90 for every metre of paint. 3 times 9 is 27, and then put the 2 zeros at the end. So the answer is 2,700 millilitres. With this question, you've just got to know what the different functions look like. So with C and D, we've got quadratic functions. One's a positive quadratic, which is a U shape. One's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that, so we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A. So to answer this question, you need to just know the answer off by heart. There is a diagram that can help us actually get there. And if we just draw a right angle triangle, and put the lengths as 1. We've got right angle here. We can use Pythagoras, a squared plus b squared equals c squared, to work out the fact that this is going to be root 2. Because it's an isosceles triangle, this angle here is going to be 45 degrees, and same with the bottom right one, but we're not interested in that. When we label it with our marked angle here, we've got the adjacent is here and the hypotenuse is here. Now we know from trigonometry that cos x equals a over h. The angle is going to be cos 45, and a is going to be 1, and h is going to be root 2. Now, this is a bit of a strange one with 1 over root 2, because we need to actually be able to rationalise the denominator. And basically what that means, if you haven't done surds yet, or you aren't doing surds, is you times top and bottom by root 2. And so we end up with root 2 over 2. So if you ever see 1 over root 2 is absolutely fine as an answer, but if you ever see the answer as root 2 over 2, the two are actually exactly the same. So writing 1 over root 2 is fine, or writing root 2 over 2 is also correct. So we notice with these simultaneous equations that the coefficients of the x's are different and the coefficients of the y's are different. But if you look at the coefficients of the y's, they are similar. If we multiply the 4 there by 3, we will get to the 12 there, and we ignore signs. I know it's a minus 12. So what we want to do is multiply everything in that equation by 3. So it's going to be 2x plus 4y equals 20. And we're just going to put our lines in, because what we want to do is multiply everything here by 3. And so we get 6x plus the 12y equals 60. And I'm just going to write that out again, so we can put in our simultaneous equation circles. And I'm just going to write the second equation again underneath, because simultaneous equations are all about working downwards. So I'm just going to show that with these circles here. Now for the coefficients that are the same, which is y, we're going to look at the signs. Are the signs the same or different? Well, if they're the same, we're going to subtract. If they are different, we're going to add. So d in different is the d in add, the s in same is the s in subtract. Well, they are different, one's a plus, one's a minus, so we are going to add. And we're going to find the sum of these. So 6x plus 3x is 9x. 12y plus minus, which is just a minus, so it's 12y minus 12y is 0, which was the whole point of adding, to get rid of those y's. And then 60 plus minus, which just means minus 42, which is going to be 18. Then we just go quickly solve that by dividing both sides by 9. And we get x equal to 3, or 2 even. So x is equal to 2. Now we need to find out what y is. So what I'm going to do is I'm just going to copy out the first equation, but I'm going to substitute in the value of x, which is 2. So we've got 2 times 2 plus 4y equals 20. Again, put my solving lines in, because the first thing I'm going to do is take away the 2 times 2, or take away the 4 from both sides. So we've got 4y equals 16, and then we're just going to divide by 4 both sides. So we get y equals 4. And we can check that with the second equation by substituting in the values of x and y. So 3 times 2 minus 12 times 4 is equal to minus 42. So when we find the mean of something, we add the elements together and we divide them by the amount of elements. So here we've got 3 elements. So what we're going to do is add these together and then divide by 3. Now the problem is that the denominators are not the same, so we can't add them yet. But they're all factors of 45. So we're going to times top and bottom of the first one by 9. So we end up with 9k over 45. Times top and bottom by 3, and so it would be 3 brackets k plus 1 over 45, and the last one is over 45, so we don't need to do anything for that. Then we can just add the numerators together, and I'm just going to expand the bracket here, so it's 3k plus 3 plus k plus 4, and then all of that over 45. And then we're going to do 9k plus 3k plus k, which is going to be 13k. And then 3 plus 4, which is just 7, over 45. So the sum of them is 13k plus 7 over 45. So to work out the mean, we need to divide it by 3. But instead of writing divide by 3, we know KFC, keep, flip, change. If you have a division, you keep the first fraction, you change the divide into a times, and you flip the second fraction. So a different and easier way of writing that is times 1/3. So here we just keep the numerator the same because we're timesing it by 1. And then the bottom we just times by the 3, which would be 135. So our answer is 13k plus 7 over 135. When we draw vectors, the top component of a vector is how far right, and the bottom is how far up. So we're going 4 right and 2 up. So I'm going to just plot a point on our graph, and I'm going to jump 4 to the right. 1, 2, 3, 4. We're going to go 2 up. 1, 2. And our end coordinate is going to be here. So we're going to just join these up with a straight line. The direction is, well, we start at the bottom left and we end at the top right. So the direction is this way. And it says to label it A. So A. So I'm going to write this equation again just a little bit bigger so we can work with it. And one of the rules with equations is you want to get rid of brackets and fractions first. So we've got a big fraction here, and basically a fraction just means divide. So we're doing the 82 and we're dividing it by 3x plus 5. Notice I've put a bracket around it, because what we're going to do is we're going to do the opposite of divide by that bracket. We're going to times both sides by 3x plus 5 to get rid of that fraction. Now on the left hand side that just gets rid of the fraction, so we're just left with 82. On the right hand side, well, we're doing the 2 times the 3x plus 5. Following my rules to get rid of all the brackets first. So 2 times 3x is 6x, 2 times 5 is 10. And you can use any method you want. Some of you might use this method where we've got the 2 here, 3x plus the 5, and then we times them, so it's 6x plus 10. That's how we can do it. Any method you like. And then we're going to take away the 10 both sides because we want x on its own. And so we've got 72 equals 6x. And then we're going to divide both sides by 6. And so we've got 12 equals x, or x equals 12. We're going to first of all find our target number by multiplying the coefficient of the x squared, which is 2, by the number on its own at the end, which is minus 25. So 2 times minus 25 will be minus 50. And the reason this number is special is because we're looking for two numbers that multiply together to make that minus 50. We're also looking for two numbers that add together to make the coefficient of the x, that positive 5 there. So, looking at the fact that they add together to make a positive, well, any numbers that times together and they end up with a negative are going to be different signs. So we know one of them is a positive and one of them is a negative. And so what I'm going to do is write down all the factors of 50 or minus 50 that are different signs. So we've got, let's have a think, we've got minus 1 and 50. We've got minus 2 and 25. We've got minus 5 and 10. And then we've just got the exact same things but the other way around. So 2 and minus 25 and 5 and minus 10. You don't need to write all of these down. If you know what the answer is going to be, you can just go straight there. And we're looking for two numbers that add together to make 5. So what I'm going to do is just put an add here. And we're just going to look through all of these and figure out which one adds together to make 5. Well, minus 5 plus 10 is going to be 5. So it's this pair here. So it's going to be minus 5 and positive 10. And so what I'm going to do now is I'm going to rewrite the question, but instead of a plus 5, I'm going to substitute in, I'm going to put in the minus 5 and the positive 10, or in this case minus 5x plus 10x. Okay, so I've just changed the plus 5x for a minus 5x plus 10x, but those do add together to make plus 5x, so I've not changed the question. And I'm going to be looking at the first two terms, and I'm going to be looking at the second two terms separately. Now you might be wondering why I've put minus 5x plus 10x and not plus 10x minus 5x. If you have the choice, always put the negative one first. Okay, it just makes it a bit easier. It means you're not dealing with negatives as much. So looking at the first box, I'm going to put down my bracket. I'm going to factorise it linearly. So we're just looking, there's no numbers that 2 and minus 5, so it's just an x. And we've got 2x and minus 5. Second box, well, they both can be 5, so it's going to be plus 5 on the outside. That would be 2x minus 5. Now notice something here, that these brackets are the same. If they're not the same, you've made a mistake. So we're going to write down the bracket there. And for the other bracket, it's just the bits left over, the bits on the outside. So the x and the plus 5 will make up that second bracket. So our answer is x plus 5, 2x minus 5, or the other way around. So you could write bracket 2x minus 5, close bracket, bracket x plus 5, close bracket. So we're going to go through one way in which you can do this question. With circle theorems, often there are multiple different approaches, and so if you do a slightly different method, but you've written down all the working and you're happy with it, and you get the same answer, it's probably fine. Just don't forget with these, always show every step of your working out, because normally, say there's 3 marks for this question, 1 will be for the answer and 2 will be for the working out. So the first thing I notice with this question is that we have a lovely triangle coming off a tangent, and whenever we have that, the angle on the outside here is equal to the angle on the opposite side of the triangle. So this is going to be 44 here. I'm just going to remove all of that, and so this is going to be 44 degrees here. So angle BFD equals 44 degrees, and the reason you need to give is the alternate segment theorem, and you have to use those words, otherwise you won't get the marks. Now next I notice that we've got a set of parallel lines here, and we've got a line going through them. And so the 44 degrees there is going to be equal to this one here. And so this is going to be 44 degrees. So we say angle FDE equals 44 degrees. And the reason this time is alternate angles. We'll put the E in, angles. And again, you have to use the word alternate. Okay, next thing I notice is that we have an isosceles triangle here, here, and here, and the bottom two angles in isosceles, assuming that it's upright, are always equal. So this is going to be 44 degrees here. So angle EFD is also 44 degrees, and again we have to just say that it's an isosceles triangle. Okay, just highlight the fact it's an isosceles triangle. Okay, next thing we're going to work out is this one here, and it's just angles in a triangle. So angle FED is going to be 180, take away the 44 plus the 44. and the reason is angles in a triangle add up to 180 degrees. And so 180 take away the 44 plus the 44 is 92 degrees. And finally, took us a while to get there, but finally we can work out what this angle is, because in total all four corners of this quadrilateral here are touching the circle, so it's a cyclic quadrilateral. And so angle, what's it called in the question, angle FBD is going to equal 180 take away 92. And again, we have to show the reason of the fact it's a cyclic quadrilateral. And so 180 take away 92 is going to be 88 degrees. So our answer will be 88 degrees. So we know that frequency density is proportional to frequency over class width. And so looking at this first bar, we've got a frequency of 12. And the class width is 10 wide. So the frequency density you would think would be 1.2, but if we look at it, it's actually 0.4. So we know that we're going to have to divide it by 3 to get there. So our formula is frequency density is the frequency divided by class width divided by 3. Okay, and so to find the next one, to find out what the frequency density is for the next one, we're going to do the frequency, which is 36, divided by the class width, which is 10, and then divide it by 3. And so when we do that, we get the answer of 1.2. And then we're just going to do the same with the next one. Frequency density is going to be the frequency, which is 12, divided by the class width, which on this one is 5, divided by 3. Then when we then do that, we get 0.8. So we're going to plot these on. So our next one is 1.2, so that goes up to 1.2. And then the last one's 0.8. An exponential growth would show an increase from left to right, but the graph we've got in front of us, or the sketch, is showing it decreasing, so it's going to be a decay. So we're going to first of all factorise the quadratic, and we'll end up with 2 brackets equals 0. And to do that, what we want to do is multiply the coefficient of the x squared and the number and so on together. So we're going to do 12 times the 6, which is 72. So we need 2 numbers that times together to make that 72. And we're also going to look at the coefficient of the x, minus 17. So we need 2 numbers that add together to make that minus 17. They need to be the same 2 numbers. So what we can do is we can write out the factors of 72 and try and find them. Or we can kind of use our head. So it's going to be minus 8 and minus 9. I knew they both need to be negative, because they add together to make a positive. Sorry, they add together to make a negative, and they multiply together to make a positive. And then just trial and error, just think it through, and get minus 8 and minus 9. So we're going to rewrite the expression on the left, but instead of minus 17, we're going to write minus 9x minus 8x, or whichever way around. So we're going to do 12x squared minus 9x minus 8x. I could have done it the other way around, plus 6. We're going to factorise linearly the first 2 terms, and we're going to factorise linearly the second 2 terms. So here we can actually divide out 3x from both of them. and we always put the minus on the outside, so it would be minus 2, and that would be 4x minus 3. The repeating bracket is our second bracket, so 4x minus 3, and then the bit on the outside, 3x minus 2, becomes our first bracket, like so. So let's put that back into our equation. And to solve this now, you get both of the brackets equal to 0. So we're going to get this equal to 0. And get our solving lines in. So we're going to add 2 to both sides. Oh, right, 3 there. Add 2 to both sides. And so we've got 3x equals 2. Then we're going to divide by 3 both sides. And we get x equals, and you can write this any way you want, but I'd write this as a fraction to keep the accuracy up. So our first solution is 2/3. And we're going to do exactly the same thing to the right hand side. Get it equal to 0. Get our solving lines in. And we're going to add 3 to both sides. So we get 4x equals 3. And again, divide by 4 both sides. And we get x equals 3/4. So our second solution is 3/4. We have a expression with f of x in, and we're given what f of x is. So what I'm going to do is just write out this expression again, but instead of f of x, I'm going to write out what it says it is. It says it is 2x plus 5. And notice I've put it in brackets as well, because f of x is the whole of that, and then plus 4. We're just going to expand the brackets, and that will make 10x plus 25 plus 4, and then 25 plus 4 is 29. So the answer would be 10x plus 29. I'm going to start by getting x equal to the 0.847 recurring, and I'm just going to show that with 3 dots. And we want to bring forward everything that's not part of the recurring pattern. So what I'm going to do is I'm going to find out what 10x is, and that's going to be 8.4747. So what I've done is I've just got the recurring pattern after the decimal point. And what I want to do now is bring forward one of the occurrences of the recurring pattern, so the 4 and the 7, just one of them. So we're going to times it by 1,000. We'll find out 1,000x, and so it would be 847.4747, etc., etc. Next, I'm going to take away everything. So 1000x take away 10x, and that's going to be 990x, and then 847.4747, etc. Take away 8.4747, etc. It's just going to be the same as 847 take away 8, because the recurring stuff will just cancel each other out. So 847 take away 8 is 839. And now I'm just going to put my lines in. And so what I'm going to do now is just divide both sides by 990. And so on the left hand side we've got x, and on the right hand side we have 839 divided by or over 990. So as a fraction it's going to be 839 over 990. So the frequency is kind of equal to the frequency density times the class width. And I say kind of because it's actually a proportional relationship. The frequency density doesn't have to be that value, it can be twice the value or half the value. But we're going to assume it is because we can check whether it is by the value given to us in the question. So going through each of the groups, the first one is 0 to 10 and it has a frequency density of 0.2. So we're just going to do 0.2 times 10, which will be 2. The next one has a width of 20 and the frequency density goes up to 0.8. So 0.8 times 20 will be 16. And the last one is a class width of 20 and it goes up to 1.2. So we're going to say that that frequency is 24. So if you do 24 plus 16 plus 2, you actually do get to 42. So we know that that is frequency equals frequency density times class width. Okay, now it says to estimate the amount of rocks that were greater than 15 kilograms. So we're going to draw a line up from 15 kilograms. And we're looking for all the values that were to the right of that line. So we know that there are 24 definitely, okay, because all of that bar is to the right of that line. And we've just got to work out what proportion of this bar is to the right of that line. Well, it's 4 squares wide, and we're looking at 3 of the squares, so it's going to be 3/4 of 16. So the amount we're looking for, so rocks, is going to be 3/4 of the 16 plus the 24. So the 3/4 of the 16 will be 12 plus the 24, which will be 36. So for this question, first thing to notice is there's a divide there, and we can actually just write this as a fraction. So 10 plus root 2 over 14 plus root 2. I'm going to keep the brackets there. We don't need them when it's in a fraction, but it will help us for the next step. So we're asked to transport this or change this into a fraction without a surd at the bottom. And so it's basically asking us to rationalise the denominator. Now, when you have two terms, including a surd at the bottom, we need to do something a bit special with this. And the thing we do is we times it by the opposite bracket. And what I mean by that is if it's 14 plus root 2, we times it by 14 minus root 2. And we've got to do the same to the top. And the reason for that is essentially here all we're doing is we're timesing it by 1, because 14 minus root 2 over 14 minus root 2 is just 1. So we're timesing it by 1, so we're not changing the fraction at all. Okay, let's draw a grid to work out what that will equal. And you can use any method you want. You can use double smiles and rainbows, FOIL, whatever method you have to multiply two such brackets. I'm going to start off with the top. The top is 10 plus root 2 times 14 minus root 2. So 14 times 10 is 140. 14 times root 2 is just 14 root 2. 10 times minus root 2 is minus 10 root 2. And then a minus and a positive make a minus, and root 2 times root 2 is just 2. Now, when you expand surdy brackets, these two and these two will add together. Okay, so we're going to start off with the numbers. 140 take away 2 is 138. And then we'll do the surd. So 14 root 2 take away 10 root 2 is plus 4 root 2. Okay, so the top is going to be 138 plus 4 root 2. And let's do the bottom. And I like these grids because you can see if you've made any mistakes quite quickly with these. You can check your working. So 14 plus root 2 times 14 minus root 2. And you'll see why in a second we do the opposite. So 14 times 14 is 196. 14 root 2 minus 14 root 2, and then minus 2. So you can see here now there's a 14 root 2 plus minus a 14 root 2. Let's just cancel each other out to 0. So we get rid of the surd. And then 196 take away 2, which is 194. So we've got 194 at the bottom. Now something we notice here is that all the terms in the fraction are even, therefore we can halve everything. So 138 halved is 69, 4 root 2 halved is 2 root 2, and 194 halved is 97. And so that would be 69 there, and that would be 2, and then that would be 97. This question is all about completing the square, but we've got to do something first. We have a coefficient of the x squared there, and we want to get rid of that. Whenever we do the completing the square, we need to have just x squared on its own, ideally. So we're going to divide out that 3, and so we're going to have 3 brackets, and then we're going to have the x squared minus 10x, close brackets, minus 11. Then we're going to complete the square with x squared minus 10x. So we're just going to copy in that 3 brackets. And how we do this is we create a bracket and we put the x at the start minus half of the coefficient of the x, so half of the 10 would be 5, close bracket, squared. Now I'm going to leave that half done because down here I'm just going to, well, across here I'm just going to expand that and show what that creates. So x times x, so that's the same as x minus 5, x minus 5. So we get x squared minus 10x plus 25. So notice here it creates this plus 25, which we've got to deal with. And we deal with that by removing the 25, which we do here. Close brackets, minus 11. So the blue parts haven't changed. The kind of turquoise parts are the completing the square bit, but the minus 25 just removes that 25 that the x minus 5 squared brackets create. Okay, so we need to get that minus 25 outside the brackets. So we're going to expand the brackets slightly. I'm going to leave the 3 on the outside of the x. In fact, let's keep the color scheme going. So we're going to have the x minus 5 squared bit there. 3 times minus 25, it's minus 75. And then we've got this minus 11 at the end. Okay, and we're very, very close to finishing. All we need to do now is sort out the minus 75 and the minus 11. And when we subtract those two, we get minus 86. Now the m part is going to be 3. The p part inside the bracket is going to be minus 5. And the q part is going to be minus 86. So I'm going to, first of all, just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, and I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is 1 section, we've got 4 of the sections from M to C. So just put little notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. And that's why it's a nice, easy way to show that A to M is 1/5 of that distance. And let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector B to M, and we know that that's going to be B to A plus A to M. We know B to A because it's labelled, it's just A. And we know A to M because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 A plus 1/5 b. And so a minus 1/5 a is going to be 4/5 a. And then we've got the 1/5 b. So it's going to be 4/5 a plus 1/5 b. Here we've got a cubic graph, and we're asked to find out what the equation would be if it was in this form here. So first of all, notice that we've got a negative cubic. A positive cubic looks like this. So we've got a negative cubic, and there is a minus sign there that just deals with that. So we don't need to worry about the fact it's a negative cubic, because that minus sign just means it's negative, fine. Next thing we want to do is find the roots. So the roots are where the line crosses or touches the x-axis. So here we can see it touches it at 6, so when x equals 6. And here, now this is an interesting one, it actually touches it twice. It touches it at -7 the first time going down, and then it touches it at -7 going up. So there's technically two roots there, sort of one root, but it counts twice because it's going down on one root and then up on the other root. So with these, what we need to do is we need to make sure that at x equals 6 and x equals -7, that this equation, the whole thing equals 0. So if we imagine a, what does a have to be to make this whole thing equal 0 when we look at this, the fact that a root is at 6? Well, if we put a at -6, we get x minus 6 in that bracket there. And if we put in the value of 6, then it's 6 minus 6, which is 0, and so the whole thing is 0, because anything times 0 is 0. So if a is -6, let's have a look at b. So what does b have to be? Well, if that's -7, if we put b as +7, then when we substitute in this -7 here into the x, we get -7 plus 7, which is 0. So if b is -7, then the whole, +7, then the whole thing will be 0 at x equals -7. And for the c, we're looking at that last root. Again, it'll be the same, won't it? It'll be x plus 7. Now, you might ask the question, how do you know which is a, which is b, which is c? Actually, it doesn't matter. We could put a at -6 and a at 7 and b at -6 and c at 7. As long as one of these is -6, one and two of these are 7, you'll always get the right answer. I'm going to start off this question by factorising the denominator of the first fraction. And so we've got 1 over, and we're going to factorise it. Now, if you want to see how to factorise it, you can see other videos we've got. I'm kind of assuming you know how to factorise this if you're watching this video. And just keep the second fraction the same. Now, you can't add fractions unless you have the same denominator. So if you look at the first denominator, the only difference between the first and the second is that 8x plus 3. So I'm going to times top and bottom of the second fraction by 8x plus 3. Now it helps us to remember that, technically that bottom expression, the x plus 2, is in brackets. So I'm going to just copy down the same first fraction, because we're not really doing anything with that. And what I'm going to do is just times top and bottom by the 8x plus 3. 1 times 8x plus 3 is just 8x plus 3. And that should do it neatly. And we've got the 8x plus 3 times the bottom, which will just give us the same denominator. So now the denominators are the same, we can just add the numerators. So it's just going to be 1 plus 8x plus 3, or in other words, it's going to be 8x plus 4. So it's 8x plus 4. And the bottom one is going to be 8x plus 3 and x plus 2. You can complete a unique version of this paper by going to our OnMath site, On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.